And welcome, Algebra, to Chapter 8, Section 3, Define and Use Zero and Negative Exponents. Zero and negative exponents. First rule, if we take a number like 7 to the 0, 7 with an exponent of 0, do you recall what that equals? I bet you do. It equals 1. Good. And so we could say as a rule, a to the 0 is 1. And so I would like to stop for just a second and look at the reasoning behind why any base to the 0 power is 1. Okay, so we were using the quotient property of exponents. And so we saw that if we have something like 7 squared over 7 to the first, you know that we actually have 7 to the 2 minus 1, right? We subtract the factor in the denominator from the 2 factors of 7 in the numerator, and we end up with 7 to the first, right? So what happens if we have 7 to the second over 7 to the second? Well, you already know that any real number divided by itself, except for 0, equals 1, right? But let's use our quotient property of exponents to prove that. So we have, if we apply the rule of quotients here, we would say we have the exponent 2, subtract the exponent of the denominator, right? So what is 2 minus 2? 7 to the 0 power. And this is why 7 to the 0 equals 1, because we know any real number divided by itself equals 1, except for 0, 0 is our special case. You may not divide by 0. Okay, so let's recall what happens with a negative exponent. And you know that we talked about this yesterday in section 8.2. A negative exponent does not make this expression negative in value at all. It's simply about location. So 3 to the negative 2 equals 1 over 3 squared. We move the power of 3 to the denominator, and look, we lose the negative, right? And 3 squared is 9, so this could be written as 1 over 9. So for our rule, when we have a base a to the negative n, we would simplify that to 1 over a to the n. An exponential expression with a negative exponent is not considered simplified. You need to move that power, and lose the negative, and now we have a simplified exponential expression. Okay, what happens if the negative exponential term is in the denominator? Well, the inverse location from here would be to move this term to the numerator. And so because there's only a 1 up there, we simply would have a to the n, right? So let's do this with a real example. If we have 1 over 4 to the negative 2, what do we have? 4 squared, which is, if you were asked to evaluate it, it is 16. Okay? Note, if we have 0 to the 0, what does that equal? Well, 0 to the 0 could be written as 0 over 0, and we just said you may not divide by 0. This is a special case, right? If you're dividing by 0, the term for that is undefined. Okay, so this is, first example, power of a quotient. 0 power of 2/3 equals, good, 1. Number 2. I have negative 8, the quantity negative 8 to the negative 2. You should pause the video and come back and see what you have. Okay, so we take this entire quantity and we move it to the denominator, right? So we have negative 8 squared in the proper location. And we could evaluate that. What is negative 8 times negative 8? 64. Good. Third problem, go ahead, pause the video and come back. If I have 2 to the negative 3 in the denominator, where should I move it? Good. The numerator, right? So 2 to the third, if we evaluate that, 2 times 2 times 2, 8. Okay, here we have more evaluating exponential expressions. So we have these. Go ahead and pause your video, do what you can with these, and come back and check your work. Okay, the first one, again, we have a negative 3. So we would move this term to the inverse location and have 4 to the third. And when we evaluate that, 4 times 4 times 4 is 64. 5 to the negative 3 to the negative 1. So now we can apply the power of a power, right? When we have negative 3 to the negative 1, we can multiply those exponents, right? We should. And we end up with 5 to the third. So you don't even have to move that term around. Just apply your power of a power. And so 5 to the third, when we evaluate that, is 5 times 5 times 5, which is 125. In number 7, we have the product of the same power, right? The power of negative 3. So when you have the product of powers, we simply do what with these exponents? Good, we add them. So in this case, we have negative 3 to the 5 plus negative 5, which is 0, which equals 1, right? And in number 8, you have an interesting expression. The numerator gives us a negative exponent. The denominator is positive. So the 6 squared stays in the denominator, but we bring the 6 squared from the numerator down, which leaves we leave a 1 in the numerator, and we end up with 6 squared times 6 squared in the denominator, which is 1 over 6 to the 4th, right? And then 6 to the 4th would be 36 squared, which is 36 squared is 1,296. So this is 1 over 1,296 when we find the value. Okay, we're again using properties of exponents that you have already explored this week. And here we have a really involved product, right? Being raised to a power of a product. So this exponent 3 is telling us that this entire term is a factor 3 times, right? So this is where we feel like we're distributing that exponent to each term because this whole thing is factor 3 times. We might write that as 3 to the third times x to the negative 2 times 3 is negative 6, right? Times y to the 2 times 3 is 6. Okay, so this is not simplified form, but it's a start. Now we will simplify. 3 to the third is 27. X to the negative 6 tells us we need to move its location, right? So we're going to end up with x to the 6th. And then the y to the 6th does not need to move. It stays in the numerator. So our simplified expression is 27 y to the 6th over x to the 6th. Let's try this again with B. Go ahead and try it and come back and check your work. Okay? Because we have like terms in columns, we can start by simplifying 4 over 8. How many 4s are on top? 1. And in the denominator we have 2. Now when I look at the second term, I have x to the negative 2. Right? So I'm going to bring these 2 x's to the denominator where I have 1 already, right? So I have 1 factor of x, and I'm adding 2 more. So in the denominator, I now have 3 factors of x. And when I look at the y terms, again, I have 4 y's in the numerator, and I have 6 y's in the denominator. So I'm going to subtract the numerators 4y and end up with y squared in the denominator. So now I have nothing in the numerator, but I really do, right? When I did this canceling 4 over 8, I do have 1, right? So when we cancel, multiplicative inverses really give us 1. If there's other factors, if there are other factors up there, we don't usually write the 1, but in this case, we need to write the 1. There's nothing left in the numerator. Okay, I know these are tricky, applying all of these properties, but step by step, if you're very careful, you should be able to be successful. So make sure that you write the original expression and then step by step to your answer, right, to your final simplified expression. So in this case, again, I see 3 over 9, so I can say I have 1 3 in the numerator, 3 3s in the denominator. So right now I'm just going to put a 3 in the denominator, and the 1, I can put the 1 there too. I don't know if I'm going to have any other terms left in the numerator, so we'll just put a 1 for now, right? And then we have x to the first in the numerator and 3 x's in the denominator. So we would subtract that 1 from the numerator and end up with 2 x's in the denominator, x squared, right? And then our y term, we have here negative 3 exponents, so I'm going to bring y to the third down. I have a y to the first down there, so how many y's do I have in my denominator? 4. And so here we have nothing else in the numerator, so 1 over 3x squared y to the 4th. Okay, one more practice problem and then you're on your own. We have 10 to the negative 27 times 10 to the 4th. So how might you write this if you wanted to simplify? Well, this is the product of powers, so we have learned that you would add those exponents, right? That might be a first step you take. So what is negative 27 plus 4? 10 to the negative 23. But this is not simplified exponential form. You're not to keep a negative exponent. So if we want to write this in simplified exponential form, we've got to move this term to the inverse location, which in this case will be the denominator, right? So our simplified exponential expression is 1 over 10 to the 23rd. Good job. Okay, here's your assignment. Have fun. Work carefully. Don't forget to start with the original expression and work carefully to your simplified expression.